Testing. 1, 2, 3. All right. Okay. Can you hear me in Calgary? Can you hear me in Calgary? Okay. Okay. How about if I talk now? Because now, are you listening? Connected? You can see me? Okay. I'm talking now. Now we can. Okay. Good. Well, yeah, I wasn't talking before, so that's good. That looks like the levels are good. I might have to speak pretty loud. Is this okay? Because if I speak this loud, then people in the back can hear me too. We've got big cohorts. Big cohorts now. Is this too loud for you? Should I turn the gain down a little bit? This is for Calgary. If it's not too loud, then we're good. I guess you got volume control there too, right? Okay. Well, let me know if you want me to change anything on my end from a technical standpoint, and I'll do my best to kind of accommodate how we can, the levels and all that. Okay. Hey, how's it going? Welcome. Day 2. Are we pumped up? I'm pumped up. I've never done a week 1 lecture before in 3 years. It's pretty, I don't know how I've avoided it for so long. And I'm not sure why that is. So this is the first time I'm doing, especially this Day 2 lecture, which is, what do we got here? The dev workflow. That looks pretty exciting, right? What did we talk about yesterday? Nothing? Orientation? Okay. So what kinds of stuff did we cover? Because I didn't watch it yesterday, and so I don't know exactly what was covered. Did we talk about the curriculum at all? No? Yes? No? Not really? So we don't really know what to expect in terms of what we'll be learning over the next 10 weeks. Do we talk about how we approach learning? Okay, good. So then I won't need to talk a lot about that, right? You'll be able to tell me how that works, I hope. Okay. So we've got Calgary joining us today. Yeah? Screen? Screen, yes. Thank you. Screen. So you didn't see my cool zoom in effect. I'll do it again. Okay, I'll do it again. Today we're talking about the dev workflow, right? Yeah. So I like to use this technique. I want to just talk a little bit about how lectures work here, kind of what the purpose is. But before that, I'll introduce myself. So my name is Carl Jensen. I've been teaching here for a little while. I'm going to take you over to my LinkedIn profile, because I don't know, it's kind of here, this me. So you can connect to me, feel like free to do it today. Usually we recommend that when career services get started, but if you want, look me up, add me, get started now. I've been a software developer for, I guess, professionally 20 years, which is, I think, a long time. It feels like a long time. I spent about 10 years making video games. Other than that, I've been doing web development. So if you're curious about my history, please come and talk to me. I don't want to spend a lot of lecture time talking about myself. I really don't like that. But if you want information, check me out on LinkedIn, or just come talk to me. That's the best way to find out sort of what I've been up to and what I do now and how I sort of approach this work. Okay, good. I got that out of the way. I really don't like that part. So we've got this remote cohort in Calgary. I don't know that they're going to be joining us every single time. I think that sometimes they'll be doing lectures on site there. But when they are joining us, I want to make sure that we're sort of including them in the process. There's some interactivity. That's actually one of the huge benefits to doing lectures, is that we can all interact. It's a little bit harder when we have this remote connection. So I want to make sure, oh, how old am I? Hafiz is asking, how old am I? I think that might just be in response to 20 years of development, right? How old do I look? How old are you? Okay, I'm 37. I don't mind telling people. All right, what was I talking about? I was talking about including Calgary. So is there anyone who is in Calgary's channel right now with their computers open? No? Could someone maybe join Calgary's channel and just be as a backup in case they ask a question like that? I've got a screen with them right here, so I can usually catch it. I've got the Slack channel open here, so I can see it here as well. But when I've got other windows up, and I don't know, I get confused easily. So if someone could just kind of join the channel and let me know if they ask a question, that would really help out. And obviously, we only have to do that when they're connected, they're tuned in. All right, and so for Calgary, please, if you have questions, ask them. I'm sorry for any delay. I don't mind going back and answering questions if I do miss them. I just really don't want to. I want you to be included. I want your questions to be heard. So today is all about that development workflow, and I want to show you as well as talk to you about it. And since I haven't done this lecture before, it's kind of a good to go over. I think for each of the days, we start with a lecture, and we can click on that, and we can kind of see what is this lecture all about. And I'll zoom in on that. That zoom doesn't work very well, so I tend to use this really focused zoom to help us out with that, right? So here we go. We're looking, what's the lecture about today? Our first technical lecture. Yes, we are going to get into some technical stuff. I'm going to be writing some code in front of you today. We're not going to focus too much on the technical solutions to problems, but more how do we approach these problems and how do we use our tools and environments to solve these problems through code, essentially. So the major topics that I'll cover today, and this is here to help me stay on course for you. Curriculum overview. So there's actually some slides that have been provided. We'll talk a little bit about each of the weeks of the 10-week program, 12-week program now. Great. And just you can ask questions. I really think it's a good idea if we're going to learn something to have sort of this high-level overview of all of the things we're going to learn, so we know where things kind of fit. Because today we're going to start with some JavaScript, and that's what we're going to be doing all week. But where do we end up in week 8? What are we doing then? It's kind of cool to know where this ends up. But we don't need to focus on really the technical parts of that, or how does automated testing work? We just need to know that's coming up. Don't worry about it, right? We'll have some time for that later on. So we're going to work through writing code incrementally. This is really important as part of the problem-solving process. How do we break our problems up into smaller little problems that are easier to solve and then apply programming concepts to those? And then we'll also talk about the basic Git workflow. So I want to try and show you, so how do we use Git to our advantage? Some people that I work with feel as though it gets in their way. It's kind of confusing. But at the end of the day, it does help all developers become more productive and efficient. So I want to show you some of the basic stuff that I use and how I operate with Git in my own day-to-day work. All right, so there's some details there which I don't need to read to you. And then what's cool is they've got these teacher notes, which actually provides quite a bit more information for me on what I could cover here. And they've actually, included if I'm not sure of what to come up on my own, because lecturers will also maybe just read that and then come up with their whole own approach to doing the lecture. I think that's actually one of the real strong points of coming to this school, is that you get a whole bunch of different perspectives. But what it says here is, if you don't know what to do, then we can, where is actually the code next to it? There it is. So they've given me an example of a piece of code we could write today. Write a node program that takes in an unlimited number of command line arguments, goes through each one, prints out the sum. So it gives me sort of a problem that I can work through. We're going to do that later. So that's kind of how the lectures work. Now, what's the purpose of the lecture, though? Like, why am I standing up here in front of you, or someone is every day, for 2 hours? What is the purpose of this? Okay, giving you a foundation to solve the problems for the day. I like that. I think that's one of my goals, is to come in here and just mostly show you what's possible. I kind of think I hear about that 4-minute mile, and then once someone ran it, it was easier for other people to do it. So if you see me do something, I feel like it's going to be easier for you to do that as well. Even if you don't know exactly how to do it when I'm doing it, and maybe I don't even teach you exactly how to do it. Maybe you don't actually learn it from me. That's okay. The material is going to walk you through that process. That's why it's there. So the labs and stuff throughout the day are meant to actually show you how to do that stuff. I just want to show you what's possible and kind of give you that higher level of view. So what else is a lecture good for? How's Calgary? What's a lecture good for? Yes, it's interactive, right? And so we're talking. You can ask me questions. I can ask you questions. I can try and pull some information out of you that might not be clear at this point. But that interactivity is a huge benefit to this type of a style, and so we don't want to miss out on that. We have the interactivity one-on-one with mentorship, very strong throughout the day. But to be able to have a group of people and talk to a group of people and sort of discuss all these things together, I think there's a real strength there. So yeah, lectures. We used to do ones in the afternoon on Mondays and Tuesdays as well. We don't do that anymore. We just reduced the time a little bit. But I think that's okay because, again, we're not necessarily trying to teach you a whole bunch of stuff during lectures. I would say that's actually not a very good thing for lecturers to do, is try and teach people things and have them come out of it with a full understanding of some concept. That's not going to happen. Maybe I believed that early on when I was more naive, but I've learned through this process that introducing things to you is good, but maybe not expecting that you're going to fully understand them. And so that means that if you come out of this lecture not fully understanding the concepts, that's no problem. That's actually, it was never really intended that you fully understand these things. But I am recording this, so we've got the stream, and that's going off to Calgary, but my goal is to record it no matter what. I want to record this lecture for you and make it available in your channel so that in 2-3 hours from now, if you want to go and review 15 minutes of what I've said, you can just go and scrub through it, or you can watch it in 2x time to catch up if that's necessary, or maybe you missed the lecture. So all of these things kind of combined work together. We do have a little bit of an artifact that's created here. Our conversation is recorded even for future cohorts. So if you feel like watching a lecture, a different lecturer for today's lecture, for example, maybe not today's, but when we go into some deep concepts, it's good to watch a couple different developers' perspective on the same topic. So I can't guarantee that every single lecture for every single topic will actually go exactly the same. We try and hit those outcomes, but we don't necessarily approach it the same way. Okay, so lectures are here for us to interact, but not necessarily to learn from. That's really what the labs are during the day and the mentorship is for. So let's go over these slides here. I think I have access to them. Cool. Okay, where's it there? I never know. Sometimes we get very interactive remote cohorts that ask questions a lot, and sometimes we don't. And either way, it's fine. Sometimes we have cohorts that are local that don't ever answer questions. And so it's my opportunity now to find out sort of which kind of cohorts we're dealing with, right? Okay. So here, I'm going to try and go through these quickly because it's really just an overview. And I'm going to send these out so that you'll be able to go and look at these as well yourself and read them a bit quicker. So as we're going through this, Don't worry about taking notes on this. Again, it's going to be sent out. So the first thing we want to cover is this concept called Fundamental Fridays. We used to do, in the middle of the program, take a week-long break, self-study, and do computer science style work, computational complexity, graphs and trees, and that types of stuff, just some more CS theory and stuff. We've now made that a bit more of a vertical slice through the program, so instead of doing it all in 1 week in the middle, we try and split it up into Fridays now. And so for the first number of Fridays, there's going to be some programming tests early on, and we get into computer science topics early on. And then later on, there's something called R&R, which is Research and Reflect, and it's an opportunity for, I think there's 2 of them in the much later weeks, where you research a topic and then write about it and submit a blog post to Medium or whatever, dev.to or whatever you want. You find a place and you publish it out there, and that's the end goal for that, is to share information. But it's educational-based learning. It's something you're educating yourself by trying to teach others things. It's actually something I use quite a bit if I need to learn a new topic. Coming up with a way to teach it to you is actually a really good way to understand it. So we're trying to give people that opportunity as well. So Fridays, it's less, we've removed a lot of the lab work, and it's a lot more of this type of fundamental style stuff. And I think it's better doing it this vertical way just on Fridays, because it sprinkles it into the program rather than having it be this one focused week. So software fundamentals, weeks 1 and 2, that's where we are right now. We've got these acronyms. I don't love that these slides are still a little bit too much text on them for me. I'm not going to read that to you, because you can read it faster than me, right? So main thing, week 1, we're focusing on this concept of focal. Focal, right? Focal is just a way for us to describe these core concepts in JavaScript or any language, really. How do we apply these concepts to solving programmatic problems? In addition to how do we take these syntax that we're learning in JavaScript, the syntax for creating functions, creating objects, and conditionals between, so logical branches. How do we actually apply that? What's our dev approach? So what are we typing into the command line? Where are we opening our files? What sort of shortcuts are we using to make our job faster? That's the type of stuff we're working on as well. And how do we debug our software? We're going to have a lot more software that's not working than we will have software that is working, because once it's working, we kind of just push it off to the side and move on to the next thing. But while it's not working, that's what we're focused on. So how do we read errors and use those errors to come up with code that will solve our problem? And then week 1, Fundamental Friday, it'll be a programming test, so mock test. The goal there is to learn how to use the test software. So I know that sounds kind of scary. You have to learn how to use the test software. But our tests are actually written as code. And what our code does is it runs your code to verify that it does what it's meant to do. So these are automated tests that are being run that contain the specifications for what your code is meant to be doing. And when you submit your code to the test software, it verifies how many of the functions actually work the way they're meant to. So the mock test is just a way for us to get used to that process of submitting this code and verifying it and getting the feedback and then fixing it. We're also going to learn a bit about recursion, so that's kind of cool. Recursion is the first kind of CS concept we're really going to focus on there. Week 2, we talk about asynchronous control flow. So JavaScript is a language that allows us, we have to write asynchronous behavior. Anytime I make a request to a server, for example, that's an asynchronous request, so I need a way to handle that. Let's not get into details about how that works or anything like that, but we are going to have to get into how do we make things happen asynchronously, and that is because we need to start working with networks communication through over HTTP. HTTP stands for the Hypertext Transfer Protocol, right? So this is a way that we can send information between our clients and our servers. So we're already, after week 1, we're already getting into some of that web-style programming, which is cool. Then we talk about NPM and packages. So this is how do we grab other people's code from repositories and use it so we don't have to write absolutely every single line. How do we create our own repositories? And how do we create our own packages, really, and manage our own software that way? We're also doing unit testing, a little bit of that. How do we verify that our software is actually working? It's much better if we write code that does our tests for us than us manually testing things every time. Early on, it's not a big deal. It doesn't take a long time for us to test something quickly. You'll see when I'm doing it today. I'll do testing without Mocha and Chai. But as our programs start to scale up in size and scope and have larger specifications, then we need to write tests that continue to verify that that code continues to work. So we're going to start that in week 2 and start that early and try and work that in throughout the whole process. How do we verify that our code is working? Programming test 2, so that's not mock anymore. That would be the one that would be sort of evaluated. That's an evaluation point. And we're going to talk about object-oriented programming in that week, or that Friday, really. OK, what else? Week 3. This is cool. First web app. So we're going to take what we learned about networking and asynchronous communication and use that to build a web server. And has anyone? It's kind of so the app is called Tiny App, and what it is, it's an app that allows you to shorten URLs. So this is not necessary anymore. But when Twitter, in 2008, when Twitter came around, we only had 160 characters to post our messages, our tweets, right? And so if you wanted to post an article link that was this long, and that was 120 characters of garbage, basically, at the end of it, then you would use up most of your tweet on that. And so what some people did was they create a service where you submit that URL to it, and it gives you back a shorter version of that URL, that when you click on that shortened version of the URL, it actually takes you to the real page. Make sense? We're going to build something like that. It doesn't have a lot of use today, because Twitter just built that right into their application, right? URLs don't count towards your 280 characters these days, or whatever it is. Okay. We'll do another programming test. The programming test is going to be on the concepts from the week before, just to try and help you know where you need to practice and study and that type of stuff. Data structures, so mostly trees. Trees are a very important data structure. That sort of theme is going to carry on throughout the following weeks afterwards. So it's a good setup for that. So that web app, we're going to do a little bit of HTML in there, not a lot of CSS. It's mostly server-side application. The following week, in week 4, that's when we go into front-end client-side development. So we're going to move from Node, where you'll be given a server already, to the browser, where you'll be loading your JavaScript into the browser, and it'll all be running in its original environment, which is the browser, not Node. Browsers, jQuery, that's a specific library we're going to be working with to manipulate something called the DOM, right? HTML, CSS, the box model, that's all client-side technology. And AJAX, that's kind of a cool word, I guess. AJAX is this concept where we can make requests from our client-side application to any web server API. We don't need to get much more into that. This is going to come from jQuery originally. So, oops, go back. There we go. And then we'll do algorithm complexity. So how do we know sort of how fast or slow our code is relative to other code? We actually have some concepts we can apply to that in the theory of computer science, and we're going to talk about that and kind of learn some more about that. So we can talk about that type of stuff somewhat in interviews. It's not going to be people understand that we did not spend 4 years learning this stuff, so we need to, but we do need to understand that it exists and even push ourselves further in that direction if we want to be doing more complex computer science style programming. So week 5, databases. We're going to learn about SQL. So how do we design databases? How do we create the tables? How do we make queries to those databases? That's what we're going to be talking about. And we're going to be using a piece of software called Postgres. Postgres, there's another piece of software called MySQL out there, which is very popular. Postgres and MySQL sit, I guess, beside each other. You could use one or the other. You wouldn't use both. Postgres has sort of taken over in terms of popularity. When I started web development in the 90s, MySQL was the popular one. But now I use Postgres. So we're going to do programming test SQL and then a midterm kickoff. So this is where it gets super exciting, because you've just learned pretty much the full stack of web development by the end of week 5. And so you're going to, oh, what? Yeah. Oh, that's kind of weird. That's out of order, isn't it? I kind of want that to be first. So I'm going to talk about week 6 before I talk about week 7 to 10. This midterm projects, we're going to take all that stuff that you learned, and not only are you going to take what you learned in the previous 5 weeks, you're going to get together with other people and what they learned as well, right? All of you, the group of 2 or 3 of you together, and all the stuff you learned in the last 5 weeks, going to build a real application. Something that we have 7 different options. So you choose one of the 7 options. You don't get to just build whatever you want. That would be the final project. You get to do that. We keep it a little bit constrained there. We also choose the technical stack, and it's basically we're using only the technologies we learned in the last 5 weeks. Maybe you can push it a little bit. I've seen people use WebSockets, for example. Feel free to do that if you want. We don't teach it yet, but we're not going to use React, for example. That's going to come later on. Use jQuery instead to do your front end stuff because it is a pretty foundational part of web development, jQuery still. Even though React is super popular these days, we do have to kind of think about our foundations, and half the web is still jQuery, so we can't really get away from it. So good real-world prep, good. Introduction to project management. So working alone, how many points of communication are there? Like 0, right? Everything happens in here, and that's hard enough as it is. But when you get together with other people and you have to add these points of communication, if I get together with one other person, how many points of communication are there? I mean, there's the one between us, let's say. Okay, so that's how I've defined. There's 2 of us, and then there's the edge between us, which is the point of communication. What happens if you have a group of 3 people? How many points of communication now? Right. But that starts to scale up, and 4 isn't 4, and 5 isn't 5, and 6 isn't 6. It scales like crazy. So we have to work on how, and it's okay, 3 people is a good starting point. I'm sure some of you have definitely worked in groups before, done group projects before, but this is how do we build a web application as a group. Communication is number 1, and we have to have an opportunity to learn all that. So that's what the week midterm project for me is all about, is yes, we're going to be building a web app. We're going to be practicing our skills from the previous 5 weeks, but really, it's how do we get together and decide which work we're going to do, who works on what order do we do that in, how do we deal with dependencies, how do we deal with things we don't understand. That's what I want to learn during week 6. Does that make sense? And during week 5, you'll learn a lot more about that, and we do a midterm kickoff, which is a lecture for 2 hours, all about how do we plan a project and talking about those things. Like we don't just drop you into that. No lectures that week, so there's no reason to have lectures that week. If there are concepts where where there's a group of people saying, you know what, I still don't quite understand HTTP and how we choose the method. That's just an example. So if a group of you said, I don't really understand this concept over here, then talk to a mentor and ask for a breakout. Because even if we don't have official lectures that week, or even in afternoons, if there's a topic that half of you are still having trouble with, it's way better for us to get together as a group, talk about it as a group, than it is for us to address it individually for each person. Does that make sense? But we need to ask you to sort of look within your group and think, what are we all sort of having, or even a group of 3 or 5 of us. If that's the case, ask a mentor to help all of you together. It really does. I think it helps you and it helps us with the amount of workload. Right? Does that make sense? Okay. So especially during week 6, your group might need a little mini breakout. Invite other groups into that. They're probably having similar problems, right? And so that week you demo to your peers. So that's the Friday. There's no test that week. And then we start into career services. So it says career and resume prep. That's when we start thinking about how do we start preparing for a job. So the first half, we don't really think about the job search. Second half is when we start building up our resume, getting feedback on it, doing the employer speed dating, and doing all that kind of stuff in preparation for our ultimate employer demo. Okay. Calgary's still good. I'm sure they'd let me know if they weren't. So then now we're moving into the second half of the program. And this is here lots of time with modern web stacks and frameworks. So we've had to choose. We start off at the basis. It's HTML, CSS, it's the DOM, it's HTTP. Those concepts are the foundation of web development. And on top of those concepts, we build React, we build Rails, we build whatever it is in Python, Laravel if you're doing PHP these days. there's lots of different stuff that we build on top, but the first week is all about building that foundation and the stuff that frameworks are built on. And then the second half is how do we actually use some of these tools that are there to help us develop software faster. And so when we go work at a company, chances are they're using React or Angular or Ember or Rails or something like this because it helps them build their application faster. We've chosen what we think happen to be still sort of popular options out there, but we can't get it right 100% of the time. So ultimately, take it as a sampler and try and learn it, use it to learn how to learn these frameworks, right? If I know how to use React, how do I take what I know about using React and apply that to Angular if I have to do that in my job? Can't get you away from that. That's the situation you'll be in. I'm sorry. So there's some details around this. It's all modern web development now. So we're doing build pipelines with Webpack. We can do real-time communication. I mentioned WebSockets earlier. Automated testing for web applications. That stuff's pretty cool. We can have software that automatically loads up the browser, and it automatically clicks on buttons and inputs text fields and hits enter and reads the screen and figures out whether or not the website is working the way that it's meant to. I'm very excited about that because I really feel like you're entering the industry after we figured testing out, whereas 2 years ago, testing absolute nightmare in JavaScript. Kind of figured out in Rails, but it's so much better than it was before, and so we have an opportunity to introduce you to that now. And hopefully, people are inspired to do some automated testing in their final projects. That would be cool. We'll do some Ruby. So that's the second language that we learn after JavaScript is some Ruby. And you are dropped into a project called Jungle Rails. It's kind of like an Amazon clone. And it's an e-commerce site where you can buy products and order things and use Stripe for checkout. A lot of it's there already, but the goal is for you to go into this existing project, have to read all about Rails. The good thing is the Rails documentation is some of the best out there. So it's actually not a bad sort of framework to use for that. And then this is where our first research and reflect is. So we'll talk about, you can research any topic you want and talk about it. And then there's some programming tests there for some Rails stuff, I believe. Okay, final projects. That to me is culmination here, right? You choose the group, you choose the technology, you choose what you're building, and we do our best to help you get it out there after 14, 15 days in front of an audience of first employers, and then later that evening, your family, friends, and everyone who's proud of you for graduating, right? So no lectures week 11 to 12. There's some advanced topics. We do a little bit of whiteboard interview prep style stuff, and then also some take-home assignments. So how do we handle those that sort of a situation where we're doing whiteboard interviews, which are scary for everyone, myself included. I try and avoid them completely, but I can help you with those because they're inevitable, right? All right. I talked about some of these already. So TinyApp Tweeter is a Twitter clone. Interview Scheduler, it's the React project we're going to build. So you can you have 5 days of the week, Monday to Friday. For each of those days, you can have a schedule, 5 hours blocks, and you can schedule an interview with an interviewer for that day. It's mostly just a front-end application. The full back-end has been provided, the API has been provided, and you build the React client that communicates with it, and then all of the tests that verifies that the code works. So you do unit tests, integration testing, and end-to-end testing on that application. And then with Jungle, that's the Rails project. It is not evaluated. So each of the 3 other projects you're going to submit for evaluation. And what that evaluation is all about, it's really simulating the code review and feedback portion of the job. Because as a junior developer, you don't, I mean, unless the company is crazy, you don't commit work directly to master. I would never let that happen. I would review it first. And that's acceptable, right, to all of you? And that's actually really not just acceptable, but you should embrace that because that's feedback. And feedback is the ultimate gift. So this is all about getting feedback. And yes, some people might have their projects rejected. But that doesn't mean you're rejected. It just means that the project did not fulfill what it needed to get through that code review process, okay? And so the feedback you're getting is really how do you improve it, and how do you get used to this code review and resubmission process, okay? That is something we get better at over 10 weeks. So maybe your Tiny app, you submit something, you get some feedback. Use that feedback when you're building your next project. Before you submit your next project, make sure you're considering all the things that someone had told you on previous feedback. We have to get better at this now. We only have 12 weeks, and this is your experience, right? You go to the job interview. How much experience do you have? This is it, like for development. So we need to get as much of that experience as we can. Excuse me. Okay, programming test, 7 in total. Yes, of course, please. So the question is, why is the last of the 4 projects not evaluated? So originally it was, and I believe we did it because of time. So if we have many cohorts overlapping, and then we have 3 cohorts finishing projects all on Friday, I think we have to say one doesn't get evaluated, and I think React ended up, or sorry, the Jungle one ended up being that one. But that doesn't mean you don't get feedback on it. That's just through mentors. So you want to ask for code reviews from mentors, and you're going to get that direct feedback that way. It's just that no one is going to go and say accept, reject at the end. But we do some testing in Rails. So it's your tests that are going to kind of confirm that some of these features work as well. But yeah, that's why. It's a time thing, unfortunately. And that's OK. I think that's OK. Yeah, so we want to finish these tests. And these are the kinds of things, like I said, where when you submit it, you get the feedback that says if you passed or failed, and you want to fix it and resubmit it and get that pass. Technical interviews. Wow. I'm spending a lot of time on this. I didn't think I would, but there's a lot to go over. I guess having not done this before, this is how it works, right? That's OK. We'll spend the second half doing the live coding. So 4 tech interviews, weeks 2 and 3, so that's next week and the week after for you. And then all the way in week 8 and 9. And again, the reason these weeks were chosen is it's, again, about overlap, right? So we don't have 2 cohorts having interviews at the same time. But the weeks 2 and 3, that's all going to be about interviewing about the stuff you learned in the previous week. So during week 2, we're going to interview about stuff from week 1. And during week 3, it's going to be about stuff from week 2. And then in week 8 and 9, that's not the case anymore. It's not about the React or the Rails that you learned in the previous weeks. It's about general, I think actually week 8 is more about database stuff. So we've actually spent a few, we've gone week 5, midterm, we've done React, and we've been a while since we've done some SQL stuff, but I think then it comes up in week 8. And then week 9 is about whiteboard interviewing. So it's about, it really is get up in whiteboard and write some JavaScript on the whiteboard, get the feedback from the interviewer, get asked questions, ask questions of the interviewer. That last interview is probably the most representative of the real technical interview, but we work it up to that point. There's some quizzes to just during the stuff. Yeah, just to try and help. The quizzes are about helping you know what sort of you understand or don't understand, because we have to go so fast here, and I wish we could take our time to figure this out, but you come up against a quiz, you answer a question wrong, and it's like, okay, well, maybe I just need to spend a bit more time on that, or review the part of the video from the lecture that day, or whatever it is, or ask for help. But please ask for help if you need it. These are all the assessment points. So completion of activities and code reviews. Code reviews are not official, really. Those are project evals. The project evals are more official code reviews. There's tech interviews. We do provide ratings on that. Usually it's just like a 1 to 4 for each question. Your quizzes, your tests, and then the assistances, which is the last. So as we're going through this process together, our relationship is 1 here at the lecture, 2 assistance requests. So at the end of an assistance, you get to put a rating for how it went. I get to put a rating for how you're doing in terms of right now in the program relative to the material. So we can kind of keep track of that, because again, things move so fast, we can't find out a week too late that someone is struggling. We need to know as early as possible because we are here to help you. That is the most important thing. I'm so glad this is now done. Any questions? I'm sure there wouldn't be. Cool. It covers everything, doesn't it? Okay. So let's at least just start this project out. I think I covered everything I wanted to. I'm going to take this problem here. Actually, I kind of liked Travis's version better. So I'm going to go down here. Here are all the lectures. I'm going to go to Travis's lecture here. You'll notice I haven't been writing any notes, right? And that's actually kind of one of my weaknesses is writing notes during a lecture. I have to write them before a lecture because I'm not very good at writing them during. So I don't have a lot of notes for you today. But Travis did. So most of the stuff I'm talking about today, he did really good notes. So the other thing I noticed here is he had a slightly different worded problem, right, than the one I had originally put there. And let's compare these two. So here. I'll just bring up another tab, I guess. So here it says, write a node program that takes an unlimited number of command line arguments, goes through each and prints out the sum of them. If any argument is not a whole number, skip it. Oh, wait a second. That is good. That's the same one he has. So my bad. I was looking at older notes. I think he's got it here. Yeah. So we used to have this problem. It wasn't defined as well. It didn't say whole number, for example. So that's a little bit ambiguous, right? It just said number, not whole number. But I think after someone had done it, because I watched a lecture from maybe 6-8 months ago, when they did it, it didn't say whole number. I like whole number more because that is very specific, right? And so we want to when we have a problem like this, we want to first be very clear about what problem we're actually trying to solve. Because it is slightly different if it's, if any argument is not a whole number, skip it. Well, that's different than not having that direction in there. And numbers could be then, if a decimal number, do we include that in it or not, right? What about negative numbers? I think those are included. So those types of things are important. I had thought that the other question wasn't asked the same way, but Travis got the exact same one off of there. So that's what we're going to work with. But before we can start with this problem, we need to break it down into less complex steps, right? Rather than looking at this as one big problem, let's break it down into smaller problems, solve those smaller problems, and then compose back together to our final solution. That means I need to start my project off, and I'm going to start from where you would start, right? Here is Lighthouse with a Vagrant file. I think I can Vagrant up here. Oh, it's telling me a new version is available. Oh no, what have I done? Oh, it's no problem. I'm going to explain all these errors as they come up. You probably won't run into this one. But let's not be afraid. That's a lot of text, right? This is a lot of text. But if you read it, it tells you exactly what's going on. Vagrant could not forward the specified ports on this VM. Does anyone not know what that means? It's okay. Everyone knows what that means? No? Okay. So when I start up my virtual machine, it's actually a different machine running on this computer. So I have the guest, and I have my host machine, which is Mac, and I have my guest machine, which is your Ubuntu Vagrant server, whatever that is, right? Two machines running now, each with their own sets of ports. Okay? So when I want to make a connection to a port for my web server, I need to forward the port from my machine here to that other machine. And so when I take a look at my Vagrant file, I can see that this is a configuration provided for me that says take all of these ports here, and when I try and connect to port 3000 on the host machine, so I'm going to go into my browser and put localhost 3000 in there and hit enter. It'll take 3000, it'll actually connect to port 3000 on my guest machine where that server is actually running. So when I try and start this up, it's going to try and do this 5 different times and forward all 5 of these ports. And what it's telling me is that when it tries to do this, when it tries to forward here, this port, that is already taken. And the reason why is because I have something running on that port already, but you probably won't. So I already have Postgres running on my Mac machine. And I can have Postgres running on my Vagrant, just like all of you do. I need to kill the one here. And it doesn't really matter how I do that. Before I can start up Vagrant, where it's going to try and take that port that's now in use, I have to stop my server running on my host machine. And then now I should be able to run Vagrant up. Yes, and all the ports are now forwarded properly. None are being used already, and my virtual machine's running. So that error I got, it told me what was happening if I just read it. I know there's a lot of text there, but they're there. The errors are there to help you, right? They don't all do a great job of that, but they are there to help you. So now I should be able to Vagrant SSH, right? So I've got two machines now, my host machine, my guest machine, and I want to now make a connection over SSH from my guest machine to my host machine. And the fastest way to do that is with Vagrant SSH. Now I've just logged into that other machine that's running on here. If I look, there's nothing in my folders here. I mean, there's, I guess, a few things. I got my Vagrant file just like you would. But this is where I would start by creating my directory structure for the whole program. And you've started this already. You have like a week 1 directory probably, right? So I'd say, here's all the work for week 1. Now I've got a bunch of different projects that I need to do on day 2 of week 1. I know you probably had a day 1 thing, but I'll do a day 2 here. And I'll go in here. And this is where all my day 2 work is going to go. Right? Now, if I have a project and it starts on day 1, I could put it in the day 1 directory. But if I have a project and I notice that it goes over multiple days, I may as well put it just in the week 1 directory, or in the week 1 directory. So I'd have week 1 with my low tide project maybe, and then day 1 with all my day 1 specific work in it. But anything low tide would still go into low tide. Day 2, specific stuff would go in there, but my low tide project I'd still do. We have to. I mean, if that's not clear to you, please ask for help with that in how to set up that structure. But for me right now, I've just got this new project that I want to build. The one defined here, which is write a node program. So writing a node program means I need to actually add a file here. And I'll probably start off by creating a folder for this project, and I'll call it sum CLI. So this is a command line tool that allows me to sum numbers. I go into sum CLI. And so here is where I actually want to start my project. I could start off by creating a source file. But this is something I'm going to put on GitHub, right? And if I'm going to put it on GitHub, then I probably want to README. That's the first thing I'm going to do. What is MD? Markdown, exactly. And so are people here comfortable with Markdown and what its purpose is? Is anyone not? This is a way for us to provide context to the content inside of plain text documents. So I'll show you what I mean by that. I can load up this README file, and I can say that this is my title of my. Actually, you know what? This is going to be better if I open it in VS Code. So I've got to go to Documents, Lighthouse, Week 1, Day 2, Sum CLI, and I'm going to actually drag. So because I'm using VS Code, I'm now deciding to take this folder, and I'm just dragging it on here. And I've loaded now that folder into VS Code. So if I bring this up in size, I am in the Sum CLI folder, and I've got my readme.markdown file here. Now, like I said, I want to provide context to the content of this file. So what's the program called? Sum CLI. And what does it do? We'll go grab our problem statement. And I'll put that here, problem statement. And I'll put that here. So this is, I'm starting to put together a README about this, and if I save it, in VS Code I can hit Command-Shift-V, and it takes me to a preview. So I get to now look at this text, right? And there's no context to any of this. What's my header? Probably, right? So by providing a little bit of context to it, that's a little bit nicer, right? And that's what Markdown's doing for me, is my file is still plain text. Like a Word document, it does the same thing, except it doesn't do it in plain text. It does, well, maybe it uses some crazy XML or something behind the scenes. But this is like a human readable with still a little bit of context on it, meaning we can do things like list all the, I can add things like list. And it just makes it easier. So when we ultimately go up to GitHub, and I can go over to I have Mocha Notes? Yeah, I do. Oh, that one. Yeah, the one I choose does not have a README. Let's do CRUD Notes. There we go. So here's the README for this other lecture somewhere. And we can see we've got context around this content. And when I go look at this, this is my readme.markdown file. Well, up here, I look at the raw version, and here's that context, right? So that's why we do it, to be able to share nicer content here on anything that can render it for us. Okay. So no questions about Markdown. We're good with that. So I'm using that for my README here. I'm going to make this a different heading. Here's my problem statement. I'm going to make that a little bit of a quote here. And as I do that, we're going to see this is what I get out of it. Again, Command-Shift-V to come into preview mode. And what I really like about this is I can split this into two windows. And as I go down, I can, well, not when I'm super zoomed in, but I can see all the stuff live as I'm typing it. So this is usually how I write my Markdown, is I just have them side by side and then. Okay. So here's my problem statement, right? This is the first iteration of my code, and I need to keep track of this. So I'm going to get init. What does get init do for me? Creates a local repo, and I'm creating in some of the sum CLI directory, right? If I create it in the day 2 directory, what do I get? Yes, a repo containing all the subprojects. All the day 2 stuff would then be in the same repo. If you want that, no problem. What if I put it in the week 1 folder? All my projects are part of the week 1 repo. That's probably not what I want, right? So when we decide where to put our Git repo, I never really nest them. Like I wouldn't put one in the week 1 folder and then put one in each of the project folders. I would just forget about the week 1 folder and only put it at the last directory, the final directory, which is my sum CLI here. So I'm only creating this repository for this one project, and I can create another repository for another project if I want, and I can put both of those on GitHub. Probably what I should be doing. Okay. So I created my empty Git repository, and I can git status. That is a very important command. Do people use this? Git status tells me everything that's going on right now for Git. Right now it says that there are some untracked files. That I've got this file here, readme.markdown. It's not being tracked. And if I want to, I can call git add and then put a file name in there. And that will include it as something to be committed. So if I say git commit, it'll say, I can't do that. We have no files staged. And so there's actually this difference between sort of the last files that were committed that we have versus our local changes that are made on top of that to ultimately what we commit as our code. So what I want to do here is git add readme, right? Okay, so if I do git add dot, what's it doing? Everything in this directory and recursively down, right? So yeah, so that'll work in most cases for us, but let's not get into the habit of only using that. we use that as a shortcut, and some people use it because it's all they know, and I don't want it to be all you know. Because if it's all you know, then this thing's stupid. I'll fix that later. If it's all you know, let me show you this problem, right? Let me show you a problem that can happen if we use get dot add dot too much, and without recklessly, let's say, okay? Make dir subdir, cd subdir, get status, get add dot, get status. What happened? Yeah, we're a layer down now, and so we're saying get add dot, and it's doing exactly what we're telling it to, which is add all the files inside the folder I'm in, and all of its children. Well, my README is a file up, so it doesn't get caught in this. If I wanted to add the README, I could say get add dot dot, and that's going to go up a directory and add all those files and everything that's a children of that. So what I'm trying to say here is get add dot is not the way to add files. It is the way to add all the files in the current directory, if that's what you want to do. Make sense? So the way that we avoid this problem is if I say get add dot, and then I say get commit, well, in this case, it's going to fail because I don't have anything to commit. But in the case that there was stuff in that folder, it would just add those things, and I would have a bunch of stuff not added. So how I solve this problem is I don't get add and then commit. I get add, and then I get status every single time. Because get add, I think I know what it's going to do. But get status confirms whether or not it did what I thought it was going to do or not, right? And here it did not do what I thought it was going to do. It didn't add the README file. Because now I've realized I need to go back here, and then when I do get add dot and get status, I've just confirmed that it did what I wanted to do. But if I commit it without status, I make mistakes, like committing my entire node modules directory, for example. One of you will do it at least, I think. Most of the time, at least one or two people do it. And it's not a big deal. We can recover from it. But it's the kind of thing that takes longer to fix than it is just to use get status and avoid it in the first place. So I've taken this file, this README file, and I've only staged it. It's not committed yet to version control. So get status is telling me that this is staged. And it tells me that if I want, I can unstage this file. So let's keep in mind that get status isn't just telling us the state, but also potentially some of our next steps. So if we don't remember, how do we remove something from staging? I just type get status, and it tells me how to remove it from staging. Make sense? Okay. Get rm cached, and then readme.markdown. Now get status tells me that's no longer tracked again, right? So I want to keep these changes. I want to commit this file. Get add readme, get status just to make sure. Get commit, and then I do -m, and here's where I can put the title of a commit message, right? I don't get to put the whole commit message here, but I can put the title of a commit message. Make sense? This is the initial commit of readme. Now, what do we put for these messages? It's hard to come up with them. Most of what I want to be doing is, what is the purpose of this? It's my initial commit. I just want to get my base readme in there. Let's say initial commit of, we know it's the readme file. I can go see what files are committed. How about problem statement? So that tells, if I go look at the list of these commits now, I can see that that's where the problem statement was added to my repository. Now when I commit this, please tell me who you are. So because I have not been doing this in Vagrant, I don't use the virtual machine very much. I just need to, I want to set this. And we'll do for the username as well. OK, now I can get commit, initial commit of the problem statement. I've committed that now. Nothing to commit anymore. And the way that I can check to see what was actually committed, because get status doesn't tell me, that's only about the working directory that I'm in right now. Get log is going to tell me what's actually been committed. And we can see here, there's one commit made by me. That's why it asked me to put all that information in there. And that commit has the initial commit of the problem statement. Okay. So let's take the break now. Come back in 10 minutes. We'll make our remote repository so we can actually put this on GitHub as well. and then we'll start solving this problem, okay? Yes, of course, yes. Yes. Is there a way to get line by line? Okay, yeah. So the question for Calgary is there a way in the command line to check to see what changes have occurred between two commits? Is that fair? Yeah. Okay. And there is. You know what? I'm going to show you that when we get back because I only have one commit right now, and we know that is just that file. But I'm going to show you how we could diff two commits later and see what was changed. I think it's a good thing to do, but I want to add another commit before I do it. Yeah. Okay. Cool. Yeah. Okay. Yeah. No problem. Yeah. So this is the kind of the problem we're running into, right? That your Git repo is 2 levels higher than where you.
Gotcha.
We can, I mean, we can fix all that, right? It will mean that you, like the easiest way to fix it is to get rid of those repos and then recreate them in the folders. You do your initial commits for each of them. After that,
so I should.
It's gonna.
And just
Well, yeah. So let's see. You know what? Let's solve this afterward. That's cool. If you come back after, we can solve it then. Let's go through this first, because then it's going to make more sense what we're doing.
That's good.
If there's a few people that have done it, we can go through it together. We can even hook up machine to the, and kind of go through how to fix it. Yeah. Mike. I'm gonna welcome back, see if Calgary's here. Hey Calgary, can I get an indication if you're all ready for us to get started again? If anyone could let me know. There. Okay, so you're ready for me to start, Sam. Thank you. Okay. So when we left off, we just started off our project. We're going to be doing some live coding, and I was looking at Travis's notes, and I just wanted to remind everyone, while we're live coding, don't try and follow along. I mean, unless you really want to, go for it, but I'm going to recommend against it. Use the video if you want to see it again. Take notes if you want, but to try and keep up is not necessary, especially since what I'm trying to do right now is just show you, not necessarily teach you, right? So, yeah, our recommendation, don't try and code along or replicate the code. If you want to do that, watch the video after and follow the steps, and then ask for help if anything comes up during that. So, we will not always understand everything in lecture codes. It's inevitable. And if there is a topic, feel free to ask for help. You can also take notes and Google stuff after, that if that's the kind of style that you like, that I encourage that. So that's kind of a preface to this. With Git, we've got what are some of the good reasons to use Git? So let's go over these quickly. Why do we use Git? Keep track of our code, version control, that's a good answer. We can actually attach to every single change. We know when it happened and who made that change. To me, this is incredibly powerful. There's been times in my own work where I've gone and I looked at a piece of code and then I don't know what it was meant to do or what it was added for, or potentially what pitfalls there could be. So I look through the version history, I find who wrote that code. It happens to be someone on my team, and I go talk to them about it. They might not remember it, but they have a better chance of knowing what it does than you do. And Git allows us to really find out that type of stuff. So you can ask them more intention and why they did things. As soon as we decide to go and push our local repository to a remote repository, now we have a backup. And as long as we continue to push from our local repository to that remote repository, then if our local machine ever died, we could clone from that remote repository, be back where we left off. So as long as we push remote, then we have a backup. Is that fair? Okay. But we don't get a free backup just by having a local repository. That is still stuff on this local machine. If this hard drive died, that stuff dies. But I actually use Dropbox or whatever, one of those services. So I actually have a cloned folder structure on a remote server that is not a Git server, but it's just cloning my local repository. So that's another way potentially to back this stuff up automatically for you, is to use one of those servers, like Google Drive or something like that. Yeah, it's a little bit harder with JavaScript because node modules end up being hundreds of thousands of files. So syncing those kind of sucks. But I ignore node modules and I don't bother syncing node modules because I can just npm install anytime I want. I would say let's just push to our remote repo and not worry about that other way of doing it. We can go back in time. So unlimited undo. As we made changes, we can go back to previous changes. No longer are we commenting out code that we want to keep for later because we're afraid of deleting it. Don't do that. Just delete it. It's still there, right? You committed it before. We can always go back to it. It makes it easy to collaborate with others. That's going to become more obvious in weeks 6 when we do the midterm project. But definitely, we can't work in groups without this type of software anymore. And we've already done a little bit of this, right? We have the working directory. I made some changes to some files. Those files, I added them to my staging. They were now staged files. Then I committed them. They're in my local repo. I did a git log, and I could see that commit history. What I want to do now is set up my remote repository so that I can start to push to remote. And that means that anyone else could access it, and I get my backup, right? So I go to GitHub. And I'm going to create a new repository. And I'm going to give this repository a name. I'm just going to name it the same as my folder because I'm lazy, but that works for me. And as long as I don't have another repository with that name, I'm going to get a green check mark. I can't have to repositories with the same name. I am going to make it a public repository. May as well. I think we know the difference, right? And then here it says, should I initialize this with a README? No, I did that myself already. I created a README, so I don't need to do it, but Git gives you the option because it's that important to them. So I'm going to create this repository. And now I get these instructions. I have not, this is an empty remote repository. They've created a bare repository on their servers just using the same Git software that we're using on this machine. And what we can do is we can connect to that repository with git remote add, so we can add a remote repository. We can call it origin, and we can give it the location, which is under my Jensen/some CLI Git repository. So I'm going to copy this here, and I'm going to git remote add origin. Actually, before I do that, I'm going to rm my subdirectory. No changes, because I didn't have any files in there, so it never tracked that. I never committed that folder. But what I want to do is git remote add origin, and then it's github.com, my repo, or my username, and then the name of the repo. So I've added this now. That has not added anything to the remote repo. It's just connected the two together. So I've created that connection now. If I ever want to see which remote repos or which remote repos I can actually push to, I can say git remote. And git remote is going to list out all of the remote repos that I've added. I could have 5, 6 different remote repos if I wanted to. Normally I have 2 or 3 of them. Origin usually happens to be my GitHub. That's what I use to push up to GitHub. So this isn't telling me that, though. If I do a git remote -v for verbose mode, that's a little bit better. I actually have this set up so that I can both fetch from GitHub, I can pull the changes from GitHub, and I can push to GitHub. Git push origin master. I type that in all the time. I just type in git push, then the name of the remote repo, and the branch I want to push. Okay, it's asking me for the username. That's because I've not set up SSH, but you set up SSH, right? So you shouldn't have to type all this in. If you have to type your name in like this, ask for mentor help, because we can set that up again. It's all in the prep work. When we go and look up how to set up GitHub, I would have to follow those steps. I'm not going to spend lecture time on that, though. So I just put in my GitHub credentials, the same stuff I used to log in to their website, and it is now pushed the remote repo to the remote repo. Now when I come here and I refresh, I have the single commit that I've made, and we can see all that commit here 23 minutes ago, and we can see that this is my some CLI with a problem statement. Right? Cool? Yes. Yeah, so for Calgary, the question is, when I look at when I create my new repo and it tells me what to do here, the second step, which I completely didn't read, I just did what I wanted to do, it said to use git push -u origin master. So the question is, what is the -u for? Okay. Oh, thank you. Okay, so I'm doing git push -help, and this is telling me -u sets the upstream. Okay. So if I use a -u, then it looks to me, it's saying it sets the upstream. What I know based on that is that it's, so now I know, like I don't use it, because I told you I just say git push origin master. Because I also sometimes do git push production staging, right? Or sometimes I'll do git push my friend's local machine. I can set up any remote one I want, some other branch master if I want. So what they're saying here is if I say git push u origin master, I'm setting the upstream branch to origin. And I believe what will happen is I can type git push after that, and it will assume I mean get push origin master. Okay, well, up to you. Follow the instructions if you want. I just type it all the time because I'm switching and I don't. But for you, it makes sense. If there's only one upstream, only one origin, well, it's nicer just to type get push all the time, right? But I don't want you to learn that typing get push is how we push everything, when ultimately you have to make decisions later on about what you're pushing and to where you're pushing it. Because we can't just forever say get push and have it know what we're doing. So it's a great question, and feel free to set it. But I think getting practice with get push origin master lets me know always push where to and what. And this is origin. I want to push the master branch. And the reason I say which branch is because sometimes I want to push my non-master branch. So I'll do that as well. I'll show you what that looks like. So let's start that process right now. I'm about to start writing some code for this. So right now I have one commit in my master branch. And I'm going to go start to make changes. And I want to bring those changes back to master later on, once I'm confident that that code works, right? I don't want to do it. I'm not going to code on master. That would be kind of unnecessary. Get branch implementation. I can call it whatever I want. Get branch gives me a list of the branches. I can see which branch am I on based on this output. Master, that's right. And if I do a get status, it's another way to find out which branch I'm on, right? Okay. So get checkout, and then I put the name of the branch. Implementation. And it tells me that I've switched to the branch implementation. So I can go back and I say get branch, and that will tell me exactly where I am right now. It'll also get status. Tell me right there. Get on branch implementation. Okay. So I'm going to make these changes, and I'm going to commit a few times as I'm going through this process. But I'm not going to take that code from here and put it back on master until I finished solving this problem. So let's go back to this problem and take a look at it. Write a node program that takes an unlimited number of command line arguments. So that tells me I'm making a command line tool, some sort of a command line interface for a program that can sum things. So I'm going to create some problem steps, and let's break these down into more specific steps that I would take. And we don't have to have code right now. We just need steps to solve this problem. So first step, I got to create a file, okay? And I create a file. What am I going to write in? What am I going to put in that file? What are the steps I need to take? What are the different? What would be a first step? We don't have to get the order right. What would be a step? Collect user input. Great. So let's do that. Collect user input. That would be definitely a step, and that seems like a very specific thing that I can do. I can get that user input. Let's say we'll call them user arguments, because they're calling them command line arguments here, but those are user inputs, yes. Okay, what would be another thing we want to do? And maybe I won't make this an ordered list right now, because we'll reorder it. Okay. Iterate over each argument. So we want a loop. Focal, right? Focal. Let's identify L in focal. Okay, what else? Iterate, not iterate, sorry. Iterate over each argument. What else do we want to do? Check it if it is whole number or not. Okay, so check if number is whole or not. Condition. So there's C in focal, right? What else? Check if number is whole or not. What else? Print things. Okay, yeah. Print out the result. Print out the result. The sum. Resulting sum. Cool. Anything else? Okay, yeah. Add two numbers together. That we need to be able to do. Add two numbers together. Anything else? No? Okay. So if we're looking at these steps, let's think we want to collect all the arguments. That does sound like a first thing we could do. We collect those arguments. And then we want to, okay, that makes sense, to iterate over each of the arguments. We would do that here. Inside the loop, do we check to see if the number is whole or not there? Okay. Now, so here we'll say if whole, add two numbers together. Else, skip the argument. And then, so now we've done this, so we go iterate over each argument. For each one, we're going to check if the number is whole or not. If it's whole, we'll add the two numbers together. Otherwise, we'll skip it. We'll go back to the next argument. We'll do the same thing over and over and over in our loop. And then when we're done, we'll print out the resulting sum. Does that make sense? Yeah? Okay. Oh, nice. That markdown is really doing well. Nicely nested lists for us. So I've just sort of pseudocoded this, right? Somewhat. We don't have any syntax here, but we have a logical approach to this problem. So I'm going to start by creating our file. And I actually like to create a source directory. You don't need to do this. You could put the file right in there. But ultimately, when you start having more source files, it does make sense to create, this is kind of conventional, to create a source folder. And then in here, I'll just call it some .js or some CLI.js. Okay. Just so I don't have to keep coming back and forth, I can always just put the problem at the top of my file here. And like that. So now I can just kind of reference this as I'm writing the program. And since we've already done the work of going through some of these steps, maybe I'll just take these here, throw them in. I have to make them comments instead. But that gives me a bit of a basis for what I'm going to write here. And today we're not really focused necessarily on how to solve this specific problem. It's more like how do we approach this workflow? What is the workflow we use to solve it? Okay, so collecting user arguments. Let's start with that. Does anybody have an idea of how to solve this problem? Because this is now a small problem, right? Okay, thank you, Andre. Determine the output. So I think that was in response to sort of what the last thing is, right? Print out this resulting sum. So we got input for Calgary that I missed. I'm so sorry. Sorry, okay. How can we collect user arguments? Process arg v. All right, so we know this. Where did we find this out? Okay. So if we don't know, though, right, we can say command line arguments node.js, right? Something like that is what we'd search for. How to parse command line arguments. It's the first option here. And if I read this, I understand what process.argv is meant to do for us, right? So this is my first clue here. Process.argv is going to do it for me. So I'm going to take that. I'm going to say, I'm going to create a function. Call it getArguments. Okay. The syntax doesn't matter so much. What this will do is return process.arg. Oh, come on. Process.argv. Now, how do we know if this works or not, right? So if I get the arguments, what I really need to do is log those arguments out. I want to find out what this function returns. Because if this function, I'm making its responsibility to get the arguments from me. Now, it might be a bit of overkill, right, to write a function just for this. But let's imagine that this problem, that there are multiple steps to get the command line arguments. Well, if we take those steps, put them into a function, then all I really need to think about is call this function and I get the arguments out of it, right? So I could just use this in my program, and then the implementation behind it could change or not, but it doesn't really matter as long as it returns the right arguments. Okay. So I'm going to console log this. And I need to run this software every little change that I make. Don't wait 10 steps. Don't do 10 steps and run your software, because which of those 10 steps did you cause the problem in? Okay, if you make one change and then you run your software, which change caused that problem? The one you did, right? So it's easier to solve. So when I sit down with you, what I want to see is little change, check. Little change, check. And get into that process of small changes with checks, quick checks. So I need to run this software right now. How do I run this program? Node. And I provide node as a parameter. What do I provide it? Sorry? The file name. And so that is under source. And then I did some CLI.js. Oops, I'll get rid of that .js. Right? So if I run this now, we expect something to come out of this, right? When I'm running my software, it's not just good enough to go and change and then check it. I also want to make a guess as to what it's going to do first and then check it. Because if I do that, if I'm wrong, I learn something. Right? Oh, and if I'm wrong, I want to learn something. So what do we think it's going to output right now? Sorry? Blank. It's a good, it's a good option, right? Because we are not, no arguments passed, right? So blank, that makes sense. This should give us back the arguments. Any other ideas of what this might give us? Sorry? The command line. Yeah, so what specifically on the command line? Right, yeah, so, okay, so it's not just the arguments. We also have other stuff stored in that variable, right? Path into node install and the file name, which actually happen to be arguments to the command line, right? So I'm providing right now those two arguments to the command line. And what I get back is this program represented as the first item, which is right here. It's the version of Node that I'm running on here, 8.9.4. The second thing is the full absolute path to the program that I'm running. That's right here. So that's what I get is an array, and no matter what Node program I run, the first two items in the array are going to be the Node program that was run and the script that was run against. Okay? If I do which node, it tells me which one gets run when I run node. And we can see that this actually matches that. This is giving me the full path to the version of node that I run when I type in node. So the which program tells me, I can do which ls or which any command that's on here. I can figure out where that program actually is installed on my machine. Okay, so now if I say, I'm going to type the word argument in there, I'm going to run it again, and I see that I actually have that in there as the third value in my array. Right? So if I want to limit it, so my goal right now for this program is to limit it to return just the array of arguments. Okay? I don't want the program, I don't want the node program, I don't want the script. How could I change this code to ensure that I only slice from the second one? This is a good answer. So slice from the second one. So slice, what does that do? If I'm not sure, I'm going to go look up array slice JavaScript, right? And I'm going to quickly read this. And what I want to caution you on with JavaScript is that these functions, slice and splice and shift and unshift and all those, all the ones listed down here, they get confusing. Splice and slice, what's the difference? Well, I could tell you, but the best thing to do is, while you're getting used to this, just go read this little intro first, just to make sure that you're using the right method for the job that you want, right? Because if I went and used splice and then into this process, it's not giving me what I want, like what's going on, and then I go read the documentation, it becomes very clear that I'm just using the wrong thing for the job. So here, returns a shallow copy of a portion of the array into a new array object. That's very informative to me. A shallow copy. We'll get into that later. Doesn't matter right now. From the beginning to the end. End not included. Oh, all this information. I don't have to spend a lot of time testing, figuring out, oh, does it include the last thing or not? It tells me right here. End is not included. Okay, well, so let's look at some examples. If I have an array that looks like this, and I want these values from it, that seems like actually exactly what I'm looking for, right? Don't worry about these. I don't want node and some CLI. I just want everything that comes after it. So it looks like slice with 2 makes sense. I'm only passing it 1 argument, whereas down here it's passing 2. Why do I only pass 1 in this case? The 2 is the beginning. Sorry? 4 is the end here. And here we're just saying to the end of the array. Like we don't give it a specific end. We just say from 2 to the end of the array. So I can get all that here. I can find out that end is actually optional because this is wrapped in square brackets. So normally in documentation, when we see these square brackets wrapping some of these parameters, well, we can see begin and end are actually both optional. Doesn't make much sense. What happens if we leave both of them out? Yeah, it's a shallow copy, exactly. Okay. Made 1 small change, right? Test it. Now I get an array with my argument here. And if I want to get closer to what I'm looking for, which is 1, 2, and 3 to be added, and maybe 10 in there as well, then I can see that I start to get closer to what I'm actually after with that. Right? Does that make sense? Okay. Now, I'm feeling pretty good about this code. Maybe I should commit it. So get status. Okay. I've modified the README. I've also got this untracked file. We can see the source down there is untracked. So I'm going to get add README. I could get add dot. It would work just fine for me. Feel free to do that if you want. I'm going to do a get add source some CLI.js, get status again just to make sure. Okay, it looks like those are the 2 files that I want to commit. I've missed one thing though. What is it? I haven't diffed. I haven't checked to see if the changes, I know that these 2 files I want to commit, but I haven't checked to see if the changes to these files are actually what I want to put in there. What if I left a console log, for example? So what I do in this case, you can get diff. Now this does get a bit complicated here. I'm going to get reset. So here it says, if I don't want these files staged right now, then I can get reset head on them. So I'm back to this state, okay? If I do a get diff, it tells me what's changed. I can see that since the last time I committed this file, I've added these lines to it, right? Now it's not showing me that other file because it's brand new. It's a new file. The change is from no file to having a file. And the way that I see that is down here. This file is completely untracked in the first place. It's not modified at all. It is untracked. So I'm going to add that stuff again. When I do get status, if I want to diff at this point, I can still do that, except I have to add a dash dash staged here to say diff against the staged stuff. Okay? Now, why am I going through this? Because I think it's really important before I commit to make sure that what I actually want to commit is what's in my files. And unfortunately, this tool is not very easy to see that. It's not very nice to use, right? So normally, when I'm doing this, I'm using a tool like this. And this is what I'm presented with here. I can see. The zoom is not working well, so I'll just zoom in. I can see. This is that new file that I created. I can see over here that this is an add. I can see that this is a modified file. These two are staged. This program just uses git. It just runs the same commands I run, but when I click on buttons instead of when I type them in and hit enter. So this might be attractive to people, right? Because it's like, well, this is if you're going to be diffing your stuff before you commit it, using a tool like this makes a lot of sense because a visual diff like this is very useful. But if I'm doing stuff like adding commit messages and stuff like that, let's get practice in the command line. So let's use that. Built into Visual Studio Code, another tool for us to use if we want. It just runs the same git commands that we run in the terminal anyways. But here we can see that we've got a diff. This is where you should be diffing your code before you commit it. So before I commit this code, I'm checking the old version against the new version, and I'm saying, yes, these are the changes that I want to commit to this repo right now. Looks good to me. This file here, brand new, yep, looks fine to me. It has our get arguments function. It runs it. It has a console log in it just to verify. I might take that out later. So what I'll do, verify, yep, it's all staged, git commit. And if I do -m, well, unfortunately, I'm only limited to one line. And this is actually where most of you are going to live, is just this with this one line. But if I want, I can actually put multiple lines into my commit message. I can say, added the get arguments function. Or let's say, added the ability to retrieve arguments. Now, I can actually put more into this message. So that -m commit, this is what you're putting in there, is the header for your commit message. But I'm actually going to put in created separate function to get arguments, updated the README with the problem steps. This is how I commit in the real world, okay? And I'm not saying you have to do this, but this is ultimately where we want to get to, is provide good information on our commits. The way that it works for me is I can just I just save this document and then Git will push that. If I do a git log, I don't just get this header, I get the whole thing. Okay? And then when I look in here, when I look in here, I can see my history. I can see all that messages here. I can also git push origin implementation. So I'm not made this any part of my master yet, right? So it's not part of master. But if I wanted to share this with someone or back up this branch, I'm going to go home and I'll come back to work on this tomorrow. But if my computer died in the next 12 hours, at least I have the branch pushed to remote. So I do that. I have to put in my credentials. And then I go look at my, I look at here, and I can see that someone pushed an implementation branch. And under here, I have master and implementation. So I can go switch over to that and see this branch is where I'm actually doing my work. And it has those new problem steps. And it has the source folder with some CLI in it. So now I'll make another change. OK, step number 2, iterate over each argument. Let's create a getSum function that takes in numbers, right? And for each of these numbers, it's gonna do a loop over them. Cool? So that's this function's responsibility, is to do the looping over the numbers. Okay. Whenever I write a function, the first thing I think of, there's two things really. What goes in and what comes out. I don't even think of the name first, right? Because, I mean, kind of here I did. I'm sorry. But like until I can't really name it until I know what comes into the function, what goes out, what its purpose is. So this function is going to receive a number of an array of numbers, or an array of values, let's say. And it's going to need to check to see if those values are whole or not as it loops over each one of them, and it will return the sum of those numbers. So which for loop should I use? Sorry? Sorry? I should check to see if it's a number. Yeah, but I want to loop through each one first, right? So comment is I need to check to see if these numbers are actually numbers, is that right? But I want to loop through each one first. So as I loop through them, I'm going to check, are you a real number? If you are, I will add you, otherwise I will skip you. So I first need to loop through these numbers. So how do I loop through numbers? A for each could work, right? Because I have an array. With a for each, I can use that on an array. Okay, let's do that. Again, I wasn't looking for a specific for loop, just one that would work. In this case, I could use a C-style for loop. I could use a for each loop. I could use a for of loop. There are lots of different options in JavaScript. They all come with their own sort of pros and cons. But for now, is just choose one. And so this numbers.forEach function, if I wasn't sure about it, I'd go look it up and I'd look and see what I'm meant to pass to this. But I know that I'm meant to pass a function to this. I'm going to pass an arrow function to this. And this function takes in the number that I'm currently iterating over. So as I go through this list, I'm going to go through each one. And I'm going to be given that number. And then inside of this function, I can do something with that number right here. So this is where I want to think about this logic, right? Iterate over each argument. I'll put that up here. Iterate over each argument. And then I'll take all this and I'll put that inside of the loop. And so check if number is whole or not. Okay, how do we do that? Modulo, okay, that's a good, yeah, modulo, okay. So what would we do? We'd say if number modulo 1, okay. And so does anyone have an idea of what that would output? If we don't know, there's a really kind of an easy way to do it. I can go right into node here, right? And I can say 12 modulo 1 gives me back 0. And I can say 12.5 modulo 1, and it gives me back 0.5. So I think this is what we're after, right? Make sense? Okay. What if I do 12 modulo 1? This, what do we get with this? Okay, cool. I mean, it's a good guess, right? Like we're not sure, but what I'm trying to show you is this is the best way to find out. Is we just go into run node alone, and it takes us into something called the REPL. Read, evaluate, print loop. So read is read some input, evaluate it, print out some output, and then keep doing that over and over. That's the looping part. So here, that looks good to me. That also looks good to me. So it looks like it does some conversion on the string to a number before the modulo operations. So that's good. We know that strings come in from the command line, right? If I say, oops, oh no, oh, gross, okay. I'll fix that. Numbers for, okay, so first thing I want to do is console log type of number. Oh, and I'll quit this. And now I'm going to run my program again. Somewhere up here. There it is. Nope, that's not what I wanted. I'll just run it. Oh, I've got an unexpected token. It's an error. Right? We're going to make a lot of these. These are here to help us. Unexpected token, and it tells us here line 21 of this file. I go look, line 21 of this file, and it looks like I just forgot. I kind of kept that in there for some reason, so let's get rid of that. Okay. So I save it. Now I don't have that. It actually kind of told me, right? If I, oops. It's kind of telling me here that there's a problem. So we're also looking for these little red squiggly lines in the editor, so that we maybe don't even need to run node to find out there's a problem. It's a little bit hard for me because I have to zoom in, but okay. So we'll run this now and see, it's kind of interesting. So what are we getting out here? What is that? What do we think that might be? Down here. That's right. The array of arguments. Exactly. So we come in here, and this is where the output is coming from. So it might actually make sense for us to label these things, right? I might say arguments, pass it, and so if I pass 2 parameters to console log, it'll print both of them out on the same line. So here, oops. So here when I run this now, oh, that's a little bit nicer. And maybe I'll put arguments colon with a space there. Okay. Well, now I don't really need to ask you all. It tells me what it is. So this is the arguments array. But I have console logged each number as I loop through it, and why is it not printing anything for me? That's a good answer, right? We're not calling the getSum function, so let's do that. GetSum. Now, I could call it with 1, 2, 3, and see. That's what I get. So if I just give, I'm not grabbing the arguments first. I'm just going to give it values that I know, 1, 2, and 3. It is telling me that those are type number. Okay, so if I head over here and I try and now emulate what I'm going to do on the command line, because I know that it passes strings in, so that's what I expect to get out of my getArguments function. See, I'm testing these things independently, because if they work independently, then I can integrate them together, right? When I run this, now it's telling me these are strings. Okay. I'm just trying to find out more about this software, and I'm using the language to do that. So instead of passing that in here, I'm going to say, get the arguments, pass those in, and now we don't get any of that output. Why is that? I didn't give it any information. Exactly. So my argument list is empty, and if my argument list is empty, then this is basically no operation, right? If I can't for each over an empty array, that doesn't do anything. So the code inside here never gets run. Therefore, we never see this log out. So I need to make sure that now in my tests, I'm including 1, 2, and 3, and maybe 10 on the command line, so that those numbers are passed as arguments. And then as we iterate through them, we print out which type they are. They happen to be strings. Well, instead of that, what we'll say is if number %1 is equal to 0, what does that, what does that tell us? Okay. Little steps verify. I'm writing code that I'm going to get rid of. I know it. I know I'm going to just remove this, and I wrote it, but it's helping me, right? So here, I'm going to give it these 3 parameters. I'm going to see that all 4 of them are whole numbers. But if I go in here and I take that one there, well, now I get the output that I would expect for those inputs, right? Cool. Okay. So if, here we go, check to see if it's a whole number or not. Put that right here. Check if number is whole or not. And then if whole, add the 2 numbers together. I'll otherwise skip the argument. Now, add the 2 numbers together. Well, I can. How do I want to do that? What 2 numbers are we adding together? Yes, the running sum in the next item in the loop. So as I go through these numbers, I'm going to take the number 1 and hopefully find the number 0 somewhere, add 1 and 0 together, take that new value, take the number 2, add it to that new value, take the next one, it was 3.5, so let's just skip it, take the number 10 and add it. So what I'd end up is 13 at the end, right? I can kind of think about how my software is going to run, and I want to get used to that as well. I want to think about, as I'm reading this code, what's going to be the result of it? I got to be a bit of a JavaScript parser as well. So add the 2 numbers. We're creating a running total. Let's do that up here. Let's say let sum equals 0 at the top. And now that I've thought about this, I actually have an opportunity to return the sum. Actually, let's not call it sum here. We'll call it total. I guess it doesn't really matter in this case. If I call this function sum, then I probably don't want to call the internal variable sum as well, because then I shadow that variable, and I wouldn't be able to access this for recursive purposes or something. So I actually like to do it this way, where I don't necessarily shadow those variables. Meaning, total is just is also a good way to represent what I'm trying to do here. I could say result would be a general output. Maybe call it output. Total for this one makes a lot of sense to me. And what I'm going to do at the end of this function is I'm going to return that total, right? So now when I call get sum, I want to actually see what this is logging out. Oh, did I not? Yeah, very good. Yeah, thank you. Okay. So I should probably label that thing. I think it's at the end here. That's 0. I'm getting sum 0 at the end, so I'll label that. Sum is 0. Okay. But I expect 13. And the reason why I don't see that is because I am only creating the value total, and I am returning the value total, but I never mutate the value total within my function. So if the number present 1 is 0, then it's whole, and I want to take the total, and I want to add to it. I want to reassign to total a new value that takes the existing value of total and adds number to it, right? Okay. What do we expect the output to be? 13, okay. Anyone else? Is that good for everyone? I can leave it up for a second. I don't want to rush anyone. 13 good? Okay. Yeah, so before we go through, let's just say 0. And then, yeah. Okay. So we think it might actually take the value 0 and add it to the string number and make it 0, 1. Okay. Yeah, that's a good thing to think about, right? Because with JavaScript, those rules are kind of hard to understand. Like, when does a conversion happen for us or not? So here we could assume maybe that when we do this, the value 0 is going to be taken, and the number 1 is going to be taken, and then it's going to actually create a string called 0, 1, or with 0 and 1. And then maybe it adds 2 to that, so you get 0, 1, 2 rather than 3, which is what we really want, right? Let's see. Yeah. So that's why we get this output here. Right? It's taking the number 0, which is our original sum, and and then we're trying to add a string 1 to it, so it coerces one of them into a string, and it concatenates the two strings together. And then it continues to do that for the values 1, 2, and 10. But it skips 3.5, right? We were successful in that. Okay. So is there a way to make sure that this value here is a number? Force it. So parse int. Yeah. How to convert a JavaScript string to a number, right? And there's lots of options. Here they're telling us that we can use parse int, parse float, number, depending on parse int or parse float. Number converts a string to a number. Wow, that sounds simple. Let's do that. Look at all this cool stuff. So where should we do that? I could do it right here, right? Because it actually doesn't matter here. We noticed that worked just fine. Even if I moduloed a string, it worked fine. But maybe what I want to do is just say, no, I know you're supposed to be a number, but because you're coming in as a command line argument, you're a string, but only until this point here, and then we switch it over, right? So I think maybe I'll do it here. This number that's being for each one will be converted. We'll do that here. I'm going to assume it works on a number just like it does a string. And here it's going to add a number now. So I hope that these two work. And that's where we get the number 13 out of it, right? Okay, so I haven't tried one thing here though, right? Which is another type of input that could come in that wouldn't, like, sorry? Spaces, I could try that, yeah. What if I do space, and what if I do, or what if I do something like ABC? That's working. But here it's saying that nan is not a whole number. Sorry? Exactly, yeah. So here, when we did this value, we tried to convert a string to a number, but that string did not have, that was not a numerical representation inside that string. So JavaScript wasn't able to infer what number we actually wanted, and what we actually end up getting back is not a number. NaN as our response for that, okay? And we can say, well, NaN is not a whole number, so that's good that it passes. Okay, well, we could just leave that there. We can also check specifically, like, is this thing not a number or not? But we have to make sure we do it with this function here. So these are some edge cases in JavaScript, things we have to deal with. But if you're interested in what is nan is there for, I actually cannot do nan is not equal to nan. Those things are not equal to each other. It's just JavaScript. So I can't explain that other than that. It's just JavaScript. So the way that we actually deal with this is through the, we can use the isNan function. It's actually kind of like we can't tell if an array is actually an array or another type of object. So we have to use isArray to determine if the thing is actually an array or not. Because in JavaScript, arrays are objects. They're objects just like anything. All right. Now, I probably want to take these console logs out, right? So let's do this. Let's take this working version. Let's get status quickly. We can see that I actually have two modified versions in here. And this is because I added the version I was working on to staging, and then I kept changing it. This is what it looks like in the other software. It's this like half line. It's basically said this thing was staged at one point, but then you changed it more, and that stuff is not staged. So we're seeing that here, and we're also seeing it right here. And the way that I get these changes into here is just through get add source some CLI again. And so now this file is modified. All of the things that I've changed since should be listed here. And we can see I removed all of this code here, or I moved it around, and I built this out of it, right? So this is my code now. I'm going to git commit -m. I'll just do a quick one. I just wanted to show you the other way before, but this is what I expect you to be doing for weeks. Yeah? Anything? Yeah. So this is kind of cool. If I change this further, and I save it, and I get diff, I'm only going to see the difference from when I last staged it. So that was only the change I just made. And if I look in here, it's showing me the same thing, is it's not the whole change, just the one I made since last time. But if I go in here and add, oops, so when I click this button, all it's doing is calling get add dot, or get add to this file. So it's adding it. Now this is the whole change again. And this is what I actually want to commit, right? I want to remove those console logs. I don't need the else condition there. That doesn't make any sense. So that's kind of what I want to commit. But let's do the two commits like I had initially planned. Okay, so I'm going to commit this code first. Get status telling me that thing is ready to go. I can also diff it one last time if I want, but I have to put staged in here now. I can see that that whole thing is going to be committed. Get add, or get commit -m, add the get, or add ability to
Some list. Yeah, exactly. List. Okay. I want to probably git log that. I can just check to see. I just added that. So there was a question about how do I diff two changes, for example, right? I can say I want to diff my current code. So I can take this commit. This commit is the unique identifier. This hash is the unique identifier for this commit. So I can use this and git diff against that change. So I can see what has changed since that commit 2 or 3 ago if I wanted to. I can also take, in here I can git log. I can take this commit here. I'm going to have to do it in another window. Because what I want to do is vagrant SSH. So what I do is I want to get log, and that's going to give me a list of all the different changes I've made. If I want to see what changes I made between the first and the second commit, but I don't really care about the changes in that third commit, I can diff this hash against, I think it's just 2 dots, this hash here, and that's showing me that these are the these were actually the changes, but they don't include any of that third code. Does that make sense? I don't know the answer to that, but I can do a git. So the other thing I use that for is git diff master ... implementation, and that's going to tell me the difference between these 2 branches. I use that quite a bit, right? Where I want to diff these 2 and ... for that. That's why I assumed I could use ... for the commit thing, which I don't do that often. I don't often commit 2 diffs like that, or diff 2 commits like that. But I will diff 2 branches and see what's different between the 2 branches. And for that, putting the 2 branch names is how I would do it. Okay, git push origin implementation. And we can see added the ability to sum a list. Okay, so we're almost there. Let's clean this up a little bit. So does it satisfy all the requirements first? Write a node program that takes an unlimited number of command line arguments. I think we've proven that unlimited amount. We can't really prove unlimited, but I put 5, and I never put anywhere in there that could only support 5, so I'm pretty sure that it'll loop through as many as I give it. It goes through and prints out the sum of them. So we did see that. We saw 13. If any of the arguments is not whole, skip it. And do support, oh, I didn't check that part yet, right? Does it support negative numbers or not? So I'm going to assume that it does right now, and just run it, run a quick test with that. So if I do it like this, I get 13. But I'm going to subtract, let's say 7, so I should get 6 back, yeah. So that's good, right? It works. I don't need to add anything more for that. But now I'm confident that this program solves this problem, and now I'm ready to refactor it. Because I'm just trying to write the sort of minimum code I need to make the thing work, and then I can understand the problem better after and go back and change some things. For example, here we realized this else statement is really just for another console log. And I don't want console logs in my committed code, so I'm going to remove that. I'm going to remove this console log completely. And I don't need to see the initial arguments. All I want is that resulting sum to happen. So that would be a little bit of a cleanup that I would do. And if I save this, I can always go and git diff and see that's the change that I made. I just removed some console logs and a redundant else statement maybe, right? That's it. Down here, get rid of some of those console logs. Just change the order of these things. Git add, git status again, git commit. Now what did I change here? Okay, cool. So here's where I'm feeling like I need to write a bit more. So I'm just going to do a git commit. I'm going to say refactor out unnecessary code, removed console.log, and removed unnecessary, or let's say redundant else, something like that, right? So now when I save this, it commits that for me. I take a look at it. It's right there. Refactor out unnecessary code. Git push origin. Now, actually, if I wanted to, I could push this to the implementation branch. But now I'm ready to merge this back to master, right? So let me show you something quickly before we do. I know that we're running over. I apologize for that. But let me show you something here. Let's say that someone else has gone and changed our master. The reason that's complaining is because I don't have a source sum.js. Let's go back. Maybe. There we go. So I'm on the master branch now. Okay. What happens? GitHub is an interface into a Git repository stored on GitHub servers. Okay. So we can use this tool to go in here and edit this stuff. Problem steps. Okay. Now someone is changing, or let's say summary write good code, something like that, right? Well, I save this. I'm committing my changes. This is what it's telling me. I'm now using GitHub to commit changes to the remote repository into the master branch. Okay. And I've just made a bunch of changes to my local implementation branch, and I've not merged them yet to my local master branch. But I want to make all this stuff work together. So here I'm saying add a summary. So I do that. It's saying commit directly to master branch. I know we're not supposed to do that. I'm going to do that for time. But GitHub also allows you to create a new branch if you want. Okay. We're going to commit that change. And we're going to see that change show up here in our list of changes. Oops. Code. I've got 2 commits now on master, including I've added this summary. So now I'm ready to merge my master. So I'm going to go and git checkout master. Oops, git checkout master. I'm going to git merge implementation. Oh, really? Okay. So if I'm so for Calgary it says so what's the name? Ted? Yeah. So Ted's saying that I've just switched over to master, but I still have that other change staged. But I believe I actually did I even switch? Yeah. Okay. Git checkout implementation. I think that I committed it. Right. Here's the commit, but I never pushed it to the remote repo. Now, I didn't push the remote repo because I don't actually necessarily care. I'm ready to merge to master, and that's where it's going to retain. That's where I'm actually going to get that refactor. It's going to be in my local version, but I might actually just delete that implementation branch from GitHub because no one else might need it. It might have just been a backup. But in order for this code to get into the remote branch, I could push remote right now, and I'd have it there. But my goal is to get this into master. So it's a good call. It's a good call out though, because if I hadn't committed that and I switched over to the other branch, I think usually Git warns me and says, oh, you have some stuff that's not staged, but you're switching branches. And if I switch to a branch where that change actually would overwrite a file that I've changed, it doesn't let you do that, which is good. So here, Git status is telling me nothing to commit. Git checkout master is going to take me back to the master branch, and I'm going to merge implementation into this branch. Okay. Now when I do a git log on master, I have my refactor in here. And if I look at this here, I can see that this master branch and this implementation branch, they are the same. And right now, I'm at the head of the master branch, which is my 4th commit. So that's where I'm sitting. And I want to git push origin master. And so I forgot my password. Try it again. This looks scary. This looks scary. Error, failed, rejected. All these negative words, right? And all this is telling me is that someone changed a file on the remote version, right? On another version of this, and you're trying to now pull that in here. Or so you're trying to push over top of that. You can't do that because you don't have all the changes. This message does a very poor job of making you feel comfortable that that's all that's happened, okay? So I want you to read these anyways, even though they have words like rejected and they failed, because what it's saying here is failed to push some refs to this because the tip of my current branch is behind its remote counterpart. So the branch that I have, this master branch, is behind the one that is remote. And so what I need to do is pull that remote one first and merge those remote changes, and then I can push my changes. I will git pull origin master. Now it's saying merge conflict and readme. Okay. It's saying, oh, two people tried to change the same thing. What's the code that I really want, though? That's all I'm thinking about right now. What do I want this to look like? That's what I want it to look like, right? I've just merged the code because I know what I want it to look like. And I know it can be hard if you didn't write it to merge other people's code. But that's why when we actually have to deal with this in midterm projects, you sit down together and do this process together, merge your code together. So here, it's saying that I have now merged this stuff in here. I want to add this now to this merged version. Now here, this is an automatic message for me. It says merge branch master. Yep. Save that. I get log. I've just merged master from the remote branch into this version. We can see that that commit here that was made by me on GitHub. And when I git push origin master now, and I will, I'll set up the SSH for next time. I mean, I set it up on my own machine. I just haven't set it up in Vagrant. Oh, it's like a 16-character password. That's why. Yes. Okay, so it's pushing that stuff up there. And what we should expect now is our master branch has all the commits from when I started, I did the project, I merged that stuff back in, I merged it with this summary, I merged the remote branch, which is where I got that from, and now I have all the stuff in here that I want, including my code. So I hope that covers the whole workflow for you. You're going to be doing that a lot this week. Ask for help. I know some people have maybe caused a bit of a mess with their Git folders. So if we want to talk about that now, I'll stop the recording and all that, and then we can just get together as a small group if there are people that need to deal with that. Yes. So the question is about a different workflow. So the first step I want to do is okay, I see what you're saying. Yep. Okay, so the recommendation is there's another workflow that we could follow, right? So I can be in. So the question is about could I pull the changes in master to implementation first, right? I can be in implementation and I can merge the changes from the remote master into my implementation branch, right? No? Right, okay, good. So I think, forgive me if this isn't correct, but I think that the question is actually more about what happens if, couldn't I just, instead of merging implementation into master and then pushing it and finding out that it's out of date, can't I just go and look to see if master is up to date first? So what I would do is I would go into master, I would pull master, the latest stuff from master, assuming someone's changed it. Let's just assume every time that when I want to merge to master, I want to pull first. Okay, so this is actually a valid way to do it. I do a get checkout master. I do a get pull origin master. So a get pull is a fetch and a merge in one step. So it's taking all the code that's on the remote master and it's bringing it down to my local master. So now my local master is different from the one that I branched implementation from, right? But then I can take implementation, I can merge master into implementation, and now implementation and master match. Now master or implementation has just the changes that are in master, but master doesn't have the implementation changes yet, right? And I can merge those back in. I can do it in any, there's lots of different ways to do it. I just showed you one of them. I mean, I can merge any branch into any other branch, though. I can merge any remote branch into any local branch. But let's try and do it where, let's not modify anything on GitHub for the first week, because then no one else is modifying anything in your repo, right? So if you don't modify anything on GitHub, then it doesn't really matter. You're always just pushing. It's only when someone else has a chance to modify something. And we'll get lots of practice with that for the midterm projects. I would say for now, if you're, feel free, pull master, and then do your merging then after. That's fine. So it's okay to do it that way. I don't have like a concrete answer for you because I actually do it that way. But I showed you the way that would show you the error, right? Because we only get the error if we try and push an out-of-date branch. If we pulled first and everything's up to date and then we push, no error. It just goes forward, no problem. Because we do all the branching or all the merging and the merge conflicts, we do all that before we even realized it was a problem. In my example, the way we found out that that was changed is by trying to push and them being different, having different changes in them. But you can do it the other way. And if you want to talk about it in detail, then we can go through exercises with, like, we can sit down and actually go through those exercises, the different ways to merge and stuff. But let's not worry about learning all the different ways. Let's get one working. Because this is something that you do not learn in the first week. You learn it over the next 12 weeks, for sure. Okay, cool. Is there anything from Calgary before we're done here? For Calgary, feel free to message me on Slack. I'm usually available for that. And send me any feedback. That's the other thing, I like feedback. I know I went quite long on this one. There's a lot to cover. Like I said, we usually have breakouts in the afternoon, but losing those has made it hard to get all this content into one session. Thanks for being patient. And I will send out Travis's notes. Sound good?